Okay, in this video we're going to be talking about rational expressions, converting them from exponential form to radical form and from radical form to exponential form. Okay, so in these, now if you see a square root, you can convert it to exponential, or back the other way, if you see it in exponential form, you can write it in radical form. Okay, so my shortcut that I think of for this is that if we're writing it into a fraction, it's always exponents over over our root. Okay, so whatever your square root is, it's this one. So if you can see the 4 is the square root, and whatever your exponent is what goes in as your exponent. So if you remember E over R, like you're going to the emergency room, ER, okay, you'll be able to solve it both directions. Okay, so if you see, there's a little 2 that sits out here. The exponent that it has is 1. So remember, it's always E over R. So you can see the exponent was 1 and the radical was 2. If you typed that into your calculator, make sure you had parentheses around your fraction. So you either type it this way or you have to type it 1 divided by 2. Okay, and then you should get, well, the square root of 36 is 6. So when you type it in your calculator, it should get you 6. So for my next one, my exponent is 1. So when I rewrite it, remember it goes E over R, so my exponent over whatever my radical is. If I type that in my calculator, I should get 4. Okay, if I move over here, exponent is 1. So when I rewrite it, it goes exponent over my radical. If I type that in my calculator, I should get 2. Okay, now it's the opposite direction, so it's exponent over radical, so we're going to radical form. Okay, so when I write it with my exponent and my radical. I could type either one in the calculator and we could see that that gets me 6. So if I'm telling you to convert to radical form, this is the answer I want. Okay, and if I go to this one, 1/2, remember this is exponent, this is my radical, so I got 7 to the first, and the exact same thing again. If I do it out the long way, 7 times 7 gets me 49. Okay, remember we can multiply them. Square root of 49 is then just 7. Okay, remember when we're multiplying things, we need to make sure that we have the same base for them. Okay, so I already have this 5. Let's break this down so that we can get it to a 5, because when we multiply things with the same base, they need to be the same. Okay, so I got 5 to 1/4. Well, 125, 5 times 25 can get me that, so I'm going to rewrite it, but I rewrite it with the same exponent. Let me erase this so I have some space. Okay, looks like I need to break 25 again because I'm still not in terms of 5. I use the exact same exponent that's attached to it. If I multiply things with the same base, I add their exponents. So 1/4 plus 1/4 plus 1/4 is 4 over 4, which is then 1. We keep the same base. Remember, multiplying things with the same base, you keep the same base, and you can add the exponents. Okay, so my next one looks like we need to get to a 3. So 9 times 3 gets me that. So when I break it, I use 1/4 as their exponents. I can break 9 to 3 and 3. So I got 3 to 1/4 times 3 to 1/4 times 3 to 1/4, and I still have this other 3. So this one followed suit, it just stays out there. I had this one following suit, and then I broke 9 to get these other ones. So when I multiply things with the same base, I keep the base, add the exponents. So when I add all those together, I should get 1. Oop. Okay, this one. I have this. Let's break this with 3 and 3. We keep the same exponent. So they still have 1/3 and 1/3. I keep the same base, add these exponents. 1/3 plus 1/3 plus 1/3 is 3 over 3, which is 1. Okay, So we kind of talked about this earlier. So when we're converting between exponential and radical form, so we're trying to get to the radical, remember it's always e over r. So when I rewrite this, I write it with my exponent and my radical. My next one, it's e over r. So when I rewrite it, I have x squared and then my radical, 5. My next one here, ooh, this one's negative. To get rid of a negative exponent, we need to drop it first. Okay, so now I have 1 over t to the positive 3/4. So when I rewrite that, remember it is e over r, so I got t cubed and the 4th root of it. Okay, if I'm just asking for you to go to radical form, you do not need to get the square root of t on the bottom away. We're just trying to get to radical form. That's as simplified as I need it. You don't need to multiply to get rid of the radical on the bottom. Okay, so here, these are going to be a lot like when we are doing exponent rules. So when I multiply things with the same base, I add their exponents, but they have to be the same base. Okay, so we keep the base, add the exponents. 1/3 plus 2/3 is 3/3, which is 1. When I do a power to a power, I multiply. So 4 times 1/2 is 2. 5 squared is then 25. In my bottom one here, remember if I don't see an exponent, I add 1s. So now I can distribute this power in. 1 times 1/2 is 1/2. Oops, that's supposed to be a 4. Ugh. And then 1 times 1/2 again is 1/2. Okay, if I rewrote this, it would be square root of 4 times square root of 5. Square root of 4 is 2. So I could keep simplifying that one if I needed to. Okay. Also, along with multiplying things with the same base, we add the exponents. Remember, if we divide things with the same base, we subtract the exponents. They're opposites of each other, so we subtract those ones. Okay, so my first example here, the exponents are both 1, so when I rewrite them with their fractions, it's going to be 1/4 times 1/3. When I multiply things with the same base, I keep the base, add the exponents to get 7/12. And then I want to convert it back to radical form, so this is my exponent, this is my radical, so 12 square root 6 to the 7th. Okay, this one, we need to do power to a power. Power to a power, we multiply, so 2/3 times negative 3 gets me negative 2. I can't have any negative exponents, so I need to drop it. I cannot change this back to any radical form because it's not a fraction, so I'm going to leave my answer like this. Okay, we're going to do power to a power and multiply, so I'm going to get x to the negative 4. We're going to have to drop it to get rid of the negative, and it's not a fraction, so I don't need to write any radicals. Okay, let's go ahead and write them. This would be 4 to 1/6 and 4 to 1/3. When I am dividing things with the same base, I subtract their exponents. So when I subtract 1/6 and 1/3, I keep the base. This should get me negative 1/6. So we're going to have to drop him to make him positive. It's a fraction, so we can go ahead and rewrite it with the square root. So my exponent's on top and my square root's on the bottom. Okay, let's go ahead and we could bring this guy up. So simplify inside your parentheses first. So I get x to 1/4 staying on top. Doesn't need to move because it's positive. And then my y to 3/4 came to the top. Power to a power, we can distribute this guy in. So 12 times 1/4 gets me 3. 12 times 3/4 gets me 9. Okay, simplify in the parentheses first to make our life easier with that fraction on the outside. So it becomes x1 x cubed. The x and negative 1 just gets moved to the top, so it's positive. We can combine these because they're like terms, so now I have x to the 4th. And now I can do power to a power. 4 times negative 1/4 is negative 1. I'm going to have to drop it to make it positive. Okay, and my last one, if I don't see an exponent, I add a 1. So I can distribute this little guy in here. So it's negative 32 to the negative 1/5, because we multiply, times y. 15 times negative 1/5 is negative 3. So we're going to have to drop both of these guys downward to make them positive. So now I got negative 32 to 1/5 y cubed. Rewrite it. 1/5 is going to be the 5th root of negative 32, and then we got y cubed still out there. And actually this simplifies to negative 2. So if I want to rewrite this here, the 5th root of negative 32 is negative 2 y cubed. So you got to see how far you can simplify. Okay, if I said to simplify this and convert it to exponential, so I want to convert it to fractions. So if it is easier to visually see, let's go ahead and split it. So the 40, and then we have the cube root of the a to the 16 times the cube root of b to the 6. So now when I write my fractions, I got 40 to 1/3 times a and 16 over 3 times b, and we got 6 over 3. Well, we can simplify that to 6 divided by 3, which would be 2. So I'm going to go ahead and simplify that to b squared. So you can split it too to make it a little bit easier writing exponential this way.